I'd like to introduce Yunhai from NS Focus to talk about mitigation bypass, past, present, and future. Yunhai?
Okay, hello everyone, thanks for coming. My name is Yunhai Zhang, and I'm a researcher of NS Focus. And I also win the mitigation bypass bounty 4 years in a row since 2015. So let's first review the past of mitigation bypass. Before 2002, that's the good old days of vulnerability exploit, because there's no mitigations at all. So exploiter is just travel. For stack buffer overrun, it's just overwrite the return address in the stack. And for heap buffer overrun, just overwrite the heap metadata. That's so simple. So once you find a vulnerability, you can achieve arbiter code execution. That's very simple. So since it was changed, there was mitigations. These are the mitigations for stack buffer overrun and the mitigations for heap buffer overrun. More important, there are general mitigations, that is the ASLR and the DEP. These two, DEP and the ASLR together, can make exploit difficult. Then you find a vulnerability, you can't simply achieve arbiter code execution. You need to do more work to achieve that. That's mitigation bypass. So there are many ways to achieve this, but most popular was first to get read-write primitives from the vulnerability, and then use this read-write capability to hijack control flow. Either corrupt the function point or corrupt the return address on the stack. Both can lead to arbiter code execution. That's the very classical mitigation bypass technique, and it has been used for many years. But when Windows 10 was released, things are changed. First, there are new release strategy. There will be 2 major updates every year, and new mitigations in each update. In the first release of Windows 10, that is the TH1, we got CFG. And in TH2, we got CIG and image load policy. In RS1, we got ACG and child process policy. And in RS2, we got CFG strict mode and CFG exporter suppression. And finally, in RS3, we got no low mandatory label image. That's an extension of the image load policy. So let's see these new mitigations. First, the most important mitigation is CFG. It's very, very simple. Just gather the indirect function call or indirect jump by validate the target. In the compare time, it will find all possible indirect function call target and collect the metadata of these functions. In the runtime, when the processor start, it will build a bitmap to mark all the valid target. And when new module are loaded, the bitmap, CFG bitmap will be updated to mark the functions in that module. Finally, when indirect function was called, there will be inserted a small code to verify that the target was invalid, which was marked from the bitmap. So with CFG, we can't simply corrupt the function pointer because the corrupted target will not be a valid one. So one way was blocked. There was still return address problem. So there's RFG. Due to some reason, RFG was not released now because current software-based implementation is not secure enough. But there will be a hardware-based implementation. So but we don't know many details of that implementation now. So in this talk, we don't cover this part. We just assume RFG will resolve the return address corruption problem. So both ways are blocked. We can't simply achieve arbiter code execution. We need new mitigation bypass techniques. There was two categories of these techniques. One, directly adversary CFG to bypass it. And the other chose alternative way to achieve arbiter code execution. First, let's see the adversary techniques. The first one is to use the unprotected code. There are many such code. That is non-CFG modules, JIT-generated code, indirect jump, and set jump, long jump, and writable IAT. All this kind of techniques has been submitted to Microsoft, so they are resolved one by one. Non-CFG module was blocked by CFG strict mode. JIT-generated code was blocked by CFG OL JIT. Indirect jump was blocked by CFG OL jump. And the set jump, long jump was blocked by long jump hardening. Finally, writable IAT are removed. So in the long run, we can consider that there will be no more unprotected code. So that way was blocked. The other adversary technique was to use valid sensitive functions such as WinExec, anti-continue, auto alloc, auto protect, heap create, map will fill, etc. That will be a very, very long list of such sensitive functions. But there was generic mitigation ways. That is to use CFG explicit separation that will explicit suppress those sensitive functions. And CFG exporter separation will make all exporter functions not valid target. In the long run, we can consider there will be no more valid sensitive functions, but there still will be wrapper functions. Here I list 4 such wrapper. They are all valid CFG target and will call those sensitive functions in its implementation. And the problem is such kind of wrapper function cannot be generic found. So they can only be addressed case by case. When one is reported, one can be resolved. So in the long run, there will be such functions, I think. So this is the first problem of current mitigations. Okay, let's see the alternative bypass technique. First is to load the library. It's very trivial to call the library to load any library once you build the read-write primitives. Here is a simple JavaScript code that can do this. So with this capability, we can use an UNC path to load a remote library which the attacker can fully control. So when this library was loaded, it will get execution. To address this, there was the no remote image policy of the image load policy, which will prevent load from the remote path. However, the browser itself will catch web page data, which can be used to deliver the library to local. So we can load the malicious library from local. So bypass the no remote image policy. To address this, there was CIG, which prevent load untrusted library. That is to say, only Microsoft assigned library can be loaded. But Microsoft assigned .NET native image is valid to be loaded, and it contains RWX section, which you can modify, use the read-write primitives. And you can write the shellcode to that section and just execute it. So there was the final mitigation is ACG, which will prevent the creation of the RWX section. If ACG is enabled, when you load such a .NET native image, it will fail to create such a section. But when we cannot load such a library to create a RWX section, we still can load an older version of NTDLL to call NT-continue. Because the system call ID are different from version to version. The ID in the current system of NT-continue is the ID of another function in the older version of NTDLL. And that function can be a valid CFG target. So we can just load an older version and call that function. It actually do what NT-continue do. So we can use NT-continue to achieve arbitrary code execution. So finally, the no low mandatory label image policy will prevent loader from catch field, because all field read by the browser will be marked as low level, so it can't be loaded. With all these mitigations, loader library technical will be blocked. So let's see the last type of mitigation bypass technical, that is to abuse feature. I have reported 4 kinds of this technical. The first is to abuse unsafe COM object. The second is to abuse JIT compile. The third is to abuse launch IE, and the last one is to abuse shim hook. Let's see one by one. For the unsafe COM object, the theory is very simple. The COM object is designed to be used in different environments. Some environment allow unsafe COM object, which can do malicious actions such as create a new process. And some environment disallow, such as our browsers. But how to determine which environment current the process is determined by some flags. So we can use the read-write primitive to modify those flags and to remove the restriction. So we can in the web browser to instantiate those unsafe COM objects and to create a new process. This is a very, very interesting feature which can be abused. And many people has used this to get the mitigation bypass bounty. This is James Forshall. He got the first top mitigation bypass bounty. And his tech is just use the unsafe COM object. And then Yang Yu, aka Tom Keeper, win the second top mitigation bypass bounty by use the similar tech like James Forshall's. And then Mozit win the third top bounty, use just similar technicals. All their technicals are built in IE, and their technicals cannot be used in Microsoft Edge because Microsoft Edge do not support ActiveX. However, I have managed to implement their technical in Microsoft Edge just by changing some flags and bring ActiveX back to Edge, and then use the same technical to achieve a bit code execution. And I have talked about that technical in the CSS conference. Now let's see the second feature can be abused, the JIT compiler. This technical I have talked about 2 years before in BlueHat. So I just simply give a simple image to show. It's very simple. Just find some place to write your shellcode and wait the JIT compiler to make that location executable, and you can run your shellcode from that location. There's many mitigations and further bypass in this topic. Since I have talked about it, so I won't talk the detail this time. And one more thing, the OOP JIT process mitigation, technical counter mitigation this attack. Ivan Franks has a talk about that. You can refer that talk for the detail. So let's see the third feature can be abused. In Microsoft Edge, there was a feature called the Launch IE. That is when you browse a website which is not compatible with Edge, it will show this, and you can click the button to launch IE to view that page. So in the internal, it's just a simple JavaScript function call. But when you call this function in your web page, you will get an error, the permission denied. This is because that function will check the URL which calls this function. So we can simply just rewrite the URL in the memory, and you can launch IE to view any URL. And since IE is not as secure as Edge, there was many exist way to achieve arbiter code execution. So you can finally execute any code. So let's see the last feature can be abused, that is the shim hook. Shims.dll will hook particular functions by modifying the IAT. This is a very powerful feature because it can modify the read-only data. You can see this code snippet. It will check the protection of the target memory and make that location writable, modify it, and revert it to the previous protection. So if we can abuse this feature, we can execute any code because you can modify any code page to write your shellcode. How the shim hook do the hook? It was guided by some metadata storing in the SP boundings structure. So you can just modify that structure to let the ishims modify any data for you, including the read-only areas, and then achieve arbiter code execution. So we can see for the future abusing techniques, there's not a generic mitigation way. It can only be resolved case by case. So this is the second program of the current mitigation. Okay, let's see the future of mitigations. First, as I has talked, that there will be the Intel CET-based RFG. This is a hardware-based RFG. Since this mitigation is not released yet, we don't know much detail, so I will not talk much about that. And the other thing is there will be fine-grained CFG. Many problem of the current safety implementation is just because it is only cross-grade CFI. So when there are fine-grade CFG, many current bypass techniques cannot be used. However, even there was fine-grade CFG, control flow still can be hijacked, I think. Because nowadays, non-trivial applications are very complicated. So there will always be indirect cause that has multiple valid targets exists. And some targets are actually not allowed because of logical reason that cannot be detected by the assembly level. So if you modify the function pointer to that logical not allow target, you can still hijack the control flow and do some malicious things. And another way of mitigation bypass is to use existing CFG bypass techniques. You can see this in the mitigation bypass bounty page. There are so many out-of-scope kind of technique. It's a long list. Many of these techniques still can be used in the future, even there was fine-grade CFG. And the last important thing is current mitigations has too many critical data protected by read-only, such as the gather dispatch echo FPTR, the IAT, the NT-use P function pointer, and the WW64 APC routines. All these important things are only protected by read-only, which could be modified to writable and then corrupt. So if we can abuse some feature to modify the read-only data, we can fully bypass the CFG and achieve arbitrary code execution. And in the end, there was still feature abusing. There's at least some possible way, such as the donut or PowerShell, to abuse delay load library, to abuse out-of-process technique and extension. All these are powerful features which can do powerful things. So if they are abused, they can potentially be used to bypass mitigations. So in the end, I think there was no silver bullet, no easy way to generate mitigation or the exploit the techniques. Our defender need to work hard to resolve all this case by case and keep working hard to resolve all the new emerging bypass techniques. So that's all. Any questions?